Hello, math magicians. Here we are again in the next lesson in algebra class. And today you're going to jot down a few notes to help you remember. And we're going to talk about polynomials. All right, so it's notes, lesson 7.1. And the topic, polynomials. Polynomials. All right. Now, before we can talk about polynomials, we first need to discuss what a monomial is. Monomial. Now, another word for monomial is term. So you'll hear me use both of those words interchangeably, monomial or term. All right, so let's start with the definition. Whoops. Let's start with the definition. Okay. A monomial could be a number. It might be a variable. Or it might be the product of a number and variables, or maybe just one variable. Okay, so it could be a number, it could be a variable, or it could be a product of a number and a variable, or variables. And it's going to have whole number exponents. With whole number exponents. Okay, that's a lot. Let's go back. Let's make sure we've got it. Monomial or term. They're the same thing. What is a monomial? What's a term? Well, it could be a number. So let's do some examples here. Example. It could be a number. 7. That's a monomial. It could be a variable. Okay. Maybe another example would be M. Or it could be the product of a number and variables. And the variables are it's going to have whole number exponents. So there's an example, 7. There's an example, M. Remember now, product means the answer to a multiplication. So you could take a number and multiply it to a variable. That would be a monomial. So 7M. 3x squared would be a monomial because they're next to each other, which means multiplication. Now you're allowed to have whole number exponents. In case you've forgotten what a whole number is, whole numbers start with 0 and count up from there, 1, 2, 3, etc. All right, so no decimal parts in between, no negatives. All right, so what's a monomial? It could be a number. It could be a variable. It could be a number and a variable multiplied together, because that's what product means. Product means multiplication. And you could have more than one variable. So you could have like 5 multiplied by x squared multiplied by y to the third multiplied by z. That's a monomial. All right? Okay, so a number, a variable, or a number and a variable multiplied. A number and a variable multiplied. A number and several variables multiplied. And the exponents are whole numbers. All right, let's look at what things that are not monomials. Things that are not monomials. All right, so what would be some examples of things that are not monomials? Remember, another word for monomial is term. So what's not a monomial? Here's something that would not be a monomial. 5 plus x. Why is that not a monomial? Because there's two things being added. All right, a 5 and an x being added. Nope, not a monomial. all right, because of that. Another thing that would not be a monomial, 3 over n. Because another way to write 3 over n is 3 times n to the negative 1. Oops, that's not a monomial, because remember, we're only allowed to have whole number exponents, and that's not, negative 1 is not a whole number. Whole numbers start with 0 and count up. Another thing that's not a monomial, 8 to the x. Not a monomial. Because we don't know, x could be anything. But if it's a monomial, it can't be anything. It can only be whole numbers. So that's an unknown there. Can't have a variable exponent. All right? So those are things that are not monomials. All right? The next thing, part C, is they talk about the degree of a monomial. Degree of a monomial. Okay? So the degree of a monomial. All right, what is that? The degree of a monomial is the sum of the exponents. The sum of the exponents of the variables. The sum of the exponents of the variables. All right? So degree of a monomial is the sum. What sum means? Sum means add, right? And you're going to add up the exponents of the variables, and that will give you the degree. All right? Let's try some examples. So here we go. Let's make a little table. And at the top we'll say monomial. And on the other side we'll find the degree. Okay? So let's start with 5x. Okay, that is a monomial. Monomials are number that can be numbers multiplied by variables, so that is one monomial. And the degree is add up the exponents with the variable. So this variable is raised to what power? Well, isn't that raised to the first power? Isn't that just x to the first power? So the degree would be 1. All right, next. 1/2 a squared times b times c to the 5th. Okay, that indeed is a monomial because it's all being multiplied. Everything's being multiplied, so that counts as one term. Now the degree, you take the exponents of the variables and you add them up. So there's a 2 and there's a 5. And now wait, here's a b to the first. So when you add those up, 2 plus 1 plus 5, that adds up to 8. All right, next. Let's say you have negative 1.7 m to the 5th. Okay, that's a monomial. Total multiplication here. No addition or subtraction separating anything. Find the exponent with the variable. And there's no other variables in exponents, so the degree is 5. All right. Let's go with 3x squared y to the 7th z to the 3rd. That's a monomial. Involves total multiplication. Add up your exponents there. That's going to add up to 12. So the degree is 12. All right, what about just a number? Let's go with 7. What degree is that? Well, there's really no variable there, right? There's no variable there. Could I put a variable, could I write like x to the 0th? You have to remember, what does x to the 0th equal? Isn't x to the 0th just 1? Okay, so that's just like, that's one way to write 7. One way to write 7 is 7 times 1. And another way to write 1 is x to the 0th. So when you have just a plain old number, the degree is 0, because there's no variable there. It's raised to the 0th power. That's different than this one. There is at least one variable, x to the 1st, that's 1. Alright, the weirdest one of all is 0. Okay, 0. Yeah, let's see, 0, you could write that as 0 times anything. You could write that as 0 times x to the 10th. You could write that as 0 times x to the 30th, right? Because when you multiply by 0, every time you multiply by 0, you get 0. So there's no way I can figure this out. There's no way I can figure this out. So this one does not have a degree. Does not have a degree. All right, I hope this is helpful. You're going to have to watch part 2. And then I can finish up and actually talk about polynomials.